All right, people. So we talked about powders in water, and we're going to move on now with a different part of the lesson. We're still doing solubility, but now we're going to talk about gases in water. But before we talk about gases in water, let's talk about this. Hey, if you have some water, right, and then you put something in it, doesn't that change the water? Here's a question for you. If I have some water and then I put a bunch of salt in it, what is one thing that immediately changes about the water besides its taste? Does it change the temperature? No. You want to, I'll give the answer. It changes the density immediately, right? A funny story about this is when I was young and working in the surf business, I got to surf this wave pool with the Rusty team one year. Rusty, that was a company that made surfboards that were, everybody liked those surfboards at the time. They were famous or whatever. So I got lucky. Like, hey, you can go surf in this wave pool. And I was like, all right. And then I went to the wave pool, and I noticed all the pros there, all the guys that were way better than me, that were legitimate, really good surfers, they all had these really thick boards. And I was wondering what they were doing. It's like, why do all these guys have these thick boards? And I just have my regular surfboard here. And as soon as I got in the water, I realized immediately why that was. Why was it? Anybody have a guess? The density of the water. That's exactly right. The density of the water was very low. It was fresh water. It was a pool. So when I got in, I sat on my surfboard. I was about this deep in the water. And I was like, oh, it's not salt water. So we don't float as well, right? And since we don't float as well, those guys already knew it. They had surfed wave pools before, and they brought a thicker board that floated better. Does that make sense? All right. Well, let's look at this. How does increasing the temperature affect how you can dissolve something? What do you think increasing the temperature does? We talked about it last week. The temperature, what is that? What is temperature? It's a measure of what? Exactly right. You at home, kids, you can't tell, but these kids are on it. They all know exactly what I was talking about. And its temperature is how fast the molecules are vibrating and how fast they're moving. It's a measure of the kinetic energy of the water. Do you remember that from last week's lesson? So if you have higher temperature, then your molecules are going to collide more frequently and with greater energy. Does that make sense? The higher the temperature, the faster your molecules are moving around. And that's the reason that our solubility graphs generally go up with temperature. Does that make sense? Now on the opposite train, we're not on the opposite train yet. Another thing, when we talk about the colligative properties of water, if we throw a bunch of salt in water, it not only changes the density, but it changes other characteristics of the water. And you want to write this down and understand it, okay? What are some other characteristics of the water that are changed? One, the boiling point goes higher. The boiling point and the freezing points both change. That's why when you're making ice cream, you'll use rock salt in your ice cream maker if you're making ice cream at home. I remember being a kid, like, oh, we got to get some rock salt. And I was like, I do not want any of that ice cream. Immediately. When my mom said, well, we're going to go to your grandmother's, we're going to make some ice cream, we've got to get some salt. I was like, no, thank you, I don't want that ice cream. You don't want any ice cream with salt in it. Well, you don't put salt in the ice cream. You put salt in the ice around it, and then it makes the ice much, much colder because we're lowering the freezing point of the water. Another thing, when you throw salt in the water, it makes the boiling point go up. Colligative means properties of the collection. So when you put salt in the water, you change the properties of the water. The boiling point is higher. Salt water boils at about 102 instead of 100 Celsius. And you lower the freezing point. Okay? So that's why we salt the roads. When we salt the roads in the winter, what does it do to the freezing point of the water? It makes it go down. Does that make sense? And if you go to Ace Hardware, you can see they sell salt for you to throw out on your steps. And down here we don't use it much, but if you've ever lived up north, very likely they throw salt on the steps in front of their house so people don't slip and fall down the stairs. You say colligative means depending on the collection. So the boiling point goes up, and what happens to the freezing point? It goes down. That's right. Another thing is putting salt in the water changes the amount of vapor pressure. So you may be saying, Mr. Perkins, what does that mean? Let's say that you have a pot of boiling water, and you have a lid on it, and the lid is going blah, 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 blah. If you take the lid off and throw some salt in and put the lid back on it, the lid won't jiggle anymore. One, because the boiling point of the water went up, but two, the pressure of the vapor coming off is lower. So there's three changes: boiling point elevation, freezing point depression, and you should write this down, vapor pressure lowering. The vapor pressure is lowered. Those are the three things. Okay. And here they are written down. And also, this one is obvious. I forgot to mention it. Increasing the osmotic pressure. And in many classes before this class, you've learned that water rushes towards the saltier or the concentrated area. You learn that in biology. It's how cells take water in and how they move water. It's also how plants take water up their roots. All right. And this is all pretty much just common sense from cooking at home. All right. Now, we're going to talk about gases. Pressure affects solubility. Remember, the last graph that we did looked like this, and we had temperature, right? Well, we could also make a graph about pressure. So now we're at the heart of our new lesson. Pressure affects solubility. Here's how you know it, kids at home. Here is a terrible, this probably tastes terrible. All right, but here is a Mountain Dew, okay? The cap is on it. There's some soda. There's carbon dioxide dissolved in this water. Now, if I do this, you can see it's fizzy. But when I take the pressure off of it, it gets even more fizzy. Why? Because the higher the pressure, the more gas you can dissolve. That's why these things have lids on them when you get them. That's why a can makes a popping sound when you open it. When you open it, you're immediately lowering the pressure inside. Does that make sense? You may also recall this happened to you 1 trillion times in your life already. So when you open the can, you take the pressure off of it, and then the gas is no longer dissolved, okay? So pressure affects solubility. And another thing, if we go back, that affects solubility is temperature. Now look at these, all of these dotted lines are going down. They're the gases. So the solubility, what happens to the solubility of a gas as the temperature increases? Can you tell me? The solubility actually does what? Decreases. So I'm going to show you that real quick. Put a little heat on here. And now you see the soda is already going flat. Because as the temperature goes up, the solubility of the liquid goes down. So just warming up our soda is making the gas not be able to stay dissolved in the water. So what I'm doing right here is literally the graph on the board behind me. Does that make sense to everyone? It's going flat immediately. All right. I'd like to hold it on there longer, but I'm worried it's going to slip out of my hand. All right. Pressure affects solubility. Okay? So we opened up the soda tried to go flat. That leads us to Henry's law. And you need to copy this down. Henry's law. The solubility of a gas at a certain pressure is equal to, proportionate to the solubility of the same gas at a different pressure, as long as we don't change the temperature. Okay? If the temperature stays the same, then just changing the pressure will change the solubility of a gas. If the temperature stays the same, you know, I need my little vacuum set up to do this right. Okay? So, solubility over pressure is equal to solubility over pressure. All right? It's okay. I appreciate it. I just forgot it. Okay. And I'm going to set you up a problem. Then I'm going to show you one more thing, and this little video will be over. Okay? Here's a problem. Let's say you have carbon dioxide, and it is 0.02 grams per liter at 1 atmosphere of pressure. Then what would the solubility be at 1.5 atmospheres of pressure? All right? So let's say we had some CO2 gas. And if the solubility was 0.02 grams per liter at 1 atmosphere of pressure, then if we increase the pressure, we're going to increase the solubility. We're going to cross multiply to get this answer. 1.5 times 0.02 divided by 1. Okay? And what does that give us? 0.03, right? So the answer is, at 1.5 atmospheres, you could dissolve 0.03 grams per liter. And that's how simple Henry's law is. It's a plug and play with only 4 letters. You're given 3 of the letters, you solve the new one. Does that make sense? And that's how you do Henry's law. The last thing I want to show you before I end this video is some things dissolve better in water or in liquids than other things. And I'm going to prove that to you. It's hard to keep a gas dissolved in a liquid. Gases are much harder to dissolve, especially at room temperature here. So I'm going to get some soda. Okay? And this soda's already kind of flat, unfortunately, because you guys remember me shaking it up. But you can still see there's some bubbles in there. Well, salt dissolves very easily in water, right? And it's hard to keep this gas dissolved in there. So if I put some salt in here, the salt dissolves, and since the salt is dissolved, right? Oh, I knew that was going to happen. I just didn't care. Since the salt dissolved, there's no room for the gas anymore. Does that make sense? So just because one thing's a gas and the other thing's a powder doesn't mean they can both be in the water at the same time. The water's only going to dissolve so much. Does that make sense? And this is a fun thing for you to do when your friend gets up from the table and put a little salt in their soda, and it'll go flat. And then they'll drink them, and they'll drink their soda, and it'll make them violently ill. And they'll have to go home. It's hilarious. Don't do that. Don't do that. All right. Does that all make sense to you? Good.